Madison College Building Construction for the Fire Service, Week 5, Homework Problem 6, Part 2. In the previous video, we all but had this solved, but we needed to find the magnitude of vector C, and then we need to combine all of the components. So we had gotten to the point that we had said that the y force in vector C was equivalent to 300 times the sine of 60 if we push that formula around. 300 times sine of 60 degrees. And again, I've already drawn that vector into this free body diagram, although I've not given it a magnitude. So we'll calculate that right now. 60 degrees, take the sine, multiply by 300. And we get a value of about 260 pounds. The x component of vector C we've already calculated, and so now we have all of the components of the resultant vector. So let's simplify this free body diagram. We'll come over here and we'll draw a new free body diagram. The vertical components are 260 pounds upward, and then 144 and 193 downward. So recall that those downward forces will just simply give a negative value. So 260 plus 144 negative plus 193 negative. There's a downward force of 77 pounds. And it's reflected by the number being negative 77 pounds. The horizontal components, same practice. We will add those that are pointing towards the right, so 150 plus 256, and then from that we will subtract the one pointing to the left. And we get a rightward force of 214 pounds. So there are a couple of things we can do. One thing is we can slide these vectors head to tail and calculate a magnitude of the resultant force. So 214, 77, and we're looking for, we know that the resultant of all of these vectors added together in this configuration is this downward and rightward pull, and specifically now we can use Pythagorean theorem to say that 77 squared plus 214 squared equals the resultant squared. If we take the square root of both sides, we get just the length of the resultant. So 214 squared plus 77 squared. So let's clear out of here. 77 squared plus 214 squared. That's the sum. Now we need to take the square root of that. So we're going to raise it to the 1/2 power. And we get a force of about 227 pounds. The last thing we need to do is figure out the heading of this. So let's calculate this angle, this included angle that I'll call angle theta. So, well, what do we know? We know two legs of this triangle and the hypotenuse. But the hypotenuse was a calculated value. It was a calculation on a calculation. So what we want probably is a function that relates the included angle, the adjacent side, and the opposite side. So again, think about the trig functions. So, ka, toa. Which of these relates opposite and adjacent? It's the tangent function. So what do we know? Tangent of theta equals 77 over 227. But the problem is we're trying to find theta. We know the ratio. So recall that when you have that problem, when the tangent machine is working backwards for you, then we're going to take the inverse tangent. Or sometimes you'll hear it called the arctangent. Arctangent of 77 over 227 is going to equal angle theta. So first thing is to just do the division problem, and the calculator is well suited to that. So 77 divided by 227. And then we're going to take the arctangent of that. So remember, to get arctangent on at least on the calculator on the computer, you have to hit inverse. And you see now you get the symbol for the inverse tangent or the arctangent. So I'm going to take the arctangent of that, and I find that it's about 18.7 degrees. Now, the last step is that, we've indicated this angle theta from kind of a rightward orientation. But if you think about the Cartesian plane, this is 0 degrees. So we need to think about that angle theta in relation to 0, right? So we've determined that this is about 18.7 degrees. The question is, to put it in standard form, what is this entire angle? Well, it's 360 minus that. So it's about 341.3 degrees. And this disagrees slightly with the answer given in the answer key. But again, there's rounding in each and every one of these steps, and so depending on the extent to which you carry decimal points, you're going to get slight differences. So this final vector is at an angle of 341.3 degrees, and it has a magnitude of about 227 pounds. So 227 pounds at 341.3 degrees. That's the solution to a fairly computationally intense vector analysis.